Welcome to the another session. Today we'll be discussing monotonicity, maxima, minima. So in this session, basically we are going to talk about what is the increasing function and decreasing function. When do we have a maximum? When do we have a minimum? And what is the monotonic function? See, if f be a real valued function with a domain D, and a comma b belongs to the domain, then f of x is said to be, see, increasing or non-decreasing. For every x1 less than x2, f of x1 is less than or equal to f of x2. So that means the function may be increasing, sometimes remains constant, then remains like this. So what happened? It is increasing but not decreasing. It is also maintaining the constant for some time. So it is not a strictly increasing one. It is only just increasing, or we call it as the non-decreasing. So algebraic approach of this one is x1 less than x2. And theoretically, if you want to go for problematic thing, for this one, f dash of x greater than or equal to 0 for all x belongs to open interval a to b. See, at a and b maybe. So I'm talking about open interval a to b. So mathematically, f dash of x greater than or equal to 0, then the function is increasing or non-decreasing. Like positive numbers and negative numbers, non-negative numbers. Non-negative numbers means what happened? Positive numbers plus 0. Non-positive numbers means negative numbers with 0. Similarly. Now strictly increasing. So x1 less than x2. F of x1 less than f of x2 means this function. Or this function. So here what happened? It is f dash of x greater than 0 for all x belongs to a to b. But the first derivative comes into the function only if the function is continuous and differentiable. Now comes to the next one. The function is decreasing or non-increasing. So x1 less than x2, but f of x1 greater than or equal to f of x2. Or here f dash of x is less than or equal to 0 for all x belongs to open interval a. Strictly decreasing, f dash of x is less than 0. F dash of x is less than 0. Okay, so if you look at everything in the one frame, okay, so this is increasing, this is strictly increasing, this is decreasing, this is strictly decreasing. Most of the times useful cases, f dash of x greater than or equal 0, f dash of x greater than 0, f dash of x less than or equal 0, f dash of x less than 0. Next, a function which is either strictly either increasing or decreasing, means either strictly increasing or strictly decreasing. We call it as the monotonic function. We call it as, means if you take increasing, then decreasing, then increasing. This is not a monotonic function. These two are monotonic functions. Okay? Now, same thing we can discuss in the other way. So, what happened? Here, this is the thing like this. I want to talk about in this particular interval only. In this particular. So, this is a minus delta neighborhood. This is a plus delta. So corresponding this value will be f of a minus delta on x-axis. This is f of a, and this is f of a plus delta. So they are talking about neighborhood of h they are talking about. So f of a minus delta less than f of a less than f of a plus delta. This function is increasing. And if you take these 3 points, if I take this is a, this will be a plus h, this will be a minus h. So look at here, this is f of a minus h. You have here f of a plus h, sorry, f of a, and this one is f of a plus h. So as a is increasing, function value is decreasing. We call it as the decreasing function. As x value increasing, function is also increasing. We call it as the increasing function. Now, composite function f of g of f of x is increasing, f of x is increasing, g of x is increasing, f of g of x is increasing. F of x decreasing, g of x decreasing, f of g of x is increasing. One of them is increasing, one is decreasing, one decreasing, the next one increasing. In that case, resultant will be decreasing. Very simple. You can concentrate on this one, like f of g of x, h of x. Go for the differentiation. H dash of x, f dash of g of x into g dash of x. If both increasing, positive, positive, total will be positive. Both are decreasing, negative into negative is also positive. One is positive, one is negative, product is negative. Negative, positive, negative. Okay? So you can take this one as. And also like f of x is increasing plus g of x is increasing. Both are increasing. Both are decreasing. Okay, you can take f of x plus g of x is also decreasing. One is increasing, one is decreasing. You cannot talk about anything. Now, what about this maxima, minima? Again, here there are the things global maxima, global minima. Okay, so this is the global minima, global maxima we are talking about. For example, x belongs to the domain, and for all values of x, f of x is greater than or equal to a particular value of f of a. Then what happened? F of a will become the minimum of the function. And for example, f of x is less than or equal to f of a for all x values, then f of a is called maximum. For example, you have a function like this. You take this is f of a. You take any other value, all these are lesser than f of a or not. So this is the maximum. And if you have like this is the minimum value. So for all values of f of x greater than or equal to f of a will be the minimum. And for all x values of domain, f of x less than or equal to f of a, then f of a is called the maximum. Okay. Now, what about this local maximum and local minimum? Look at here, if I take a function like this, y is equal to x cube. There is no minimum, there is no maximum because minimum is minus infinity, maximum is plus infinity. Okay, so let me take, I have taken a wrong example because it is the inflection is there. Okay, so you have a curve like this. It is keep on going up to plus infinity, this is going up to minus infinity. So for this one, there is no global maximum and global minimum. These are need to be fixed values. But whereas this is called the local maxima and this is called the local minimum. What is meant by this local minima and what is meant by this local maxima? So that's why we are giving here special thing. F of A minus H is less than F of A is greater than or equal to F of A plus. So whether function is continuous, discontinuous, etc. If this is holds good, F of A is local maximum. Because in the neighborhood of A, this is negative. So let me take this is one function. A is here, A minus H, A plus H will be here. Okay. And look at here. This function is continuous and differentiable, and this function is not differentiable, but still okay. And you have a function like this. Okay, so in all these cases, this possibility is there. In all the possibilities, this value is local maximum. See, generally what happened, function is continuous and differentiable. Function is continuous, function is neither continuous nor differentiable. Next one is for vice versa of this. What is that? Sorry, local minimum. Curve is like this. Curve is like this. Curve is like this. So this is coming here. So continuous f of A is less than f of A plus H is less than f of A minus H. So A minus H and f of A plus both are greater than this. In this case and in this case and in this case. So we can call it as local maxima, local minima. So what is the local maxima and local minima we talk about? F of A minus is less than or equal to f of A is greater than or equal to f of A plus H. F of A is local maxima. And f of A minus H greater than or equal to f of A less than or equal to f of A plus H. F of A is local minimum. Why local minimum, local maximum? Look at it. If I take a curve like this. So this is local minimum, this is local maxima, local maxima, local minima, local minima, local. Look at your local maxima at this position lesser than the local minimum. Okay? And minimum among all the local minimums. Okay? Will be global minimum. But not always, because if you take this one, this function is coping like this. This is local minima, this is local minima, local. Minimum among these three is this one. But can we take it as the global minima? No, you cannot take. Okay. And similarly, maxima among all the maxima. If the function is continuous and defined in the closed interval, then minimum among local minimums will be global minima. Maximum among all the local maximums will be the global maximum. F dash of A is equal to 0, we call it as the stationary point. So stationary point means generally you are going to get either minima or maxima at that. Means the position, the derivative rate of change becomes 0 and changes the direction. Only very few cases are there as a special case like F dash of A is equal 0, F dash double dash of A is equal 0 and few more things. Then we call it as point of inflection. Point of inflection. Next, what is meant by critical point? Critical point means either F dash of A is equal 0 or F dash of A does not exist. Okay. F dash of A is equal 0 or F dash of A does not exist. We call it as the F dash A does not exist means F of A is not continuous is also part of that. And critical points are the points where we have to check for the existence of minimum and maximum values of a function. Next. So how we are going to find out the maxima minima of a particular given function? What is the approach? Like y is equal to f of x is continuous and differentiable. Then first we need to calculate f dash of x. Second step, find x is equal to alpha such that f dash of alpha is equal to 0. Third step is find f double dash of x. Fourth step is f double dash of alpha greater than 0. Then f of alpha is minimum and f double dash of alpha less than 0. F of alpha is maximum. This is where if the function is continuous and differentiable. Okay. Next one is if the function is continuous, not differentiable. Not differentiable. Means the curve is like this. A curve is like this. So what I'll do is here function is increasing. That means f dash of, if for example this is x is equal to a, f dash of a minus greater than 0 and this side function is decreasing, f dash of a plus is negative. So f dash of a minus positive and f dash of a plus is negative. So that means function is increasing then decreasing, then f of a is maximum. Here you look at here a, but left side of this one is function is decreasing. That means f dash of a minus negative and right side is increasing. F dash of a plus is increasing. So in this case, f of a is minimum. Okay. So previous case, can we use this same case for the previous case? Yes, you can use this one for the previous case also. Next one is function is neither continuous nor differential. Means discontinuous. You have like this. This point is. So I need to talk about x is equal to. Clearly here, f of a minus is less than f of a is greater than f of a, f of a plus. So right limit, left limit. So this is maximum. Now for example, if the curve is like this point is including like this. So here no, because here f of a minus is greater than f of a is less than f of a plus. So this is not the local, sorry, this is not the maxima. So for this type of things, only thing is f of a minus is less than f of a is greater than f of a plus. This is the maxima. F of a minus is greater than f of a is less than f of a plus. In this case, we call it as minimum. Now, previous two cases can be solved by using this part also. Okay, previous two things can be taken this one. So, simply if I want to give in a single line, maxima. One is f dash of a is equal to 0, f double dash of a is negative, or f dash of a minus is greater than 0, f dash of a plus is less than 0, or f of a minus h less than f of a is greater than f of a plus h. For minima, f dash of a is equal to 0 and f double dash of a is greater than 0, or f dash of a minus is less than 0, f dash of a plus is greater than 0, f of a minus h greater than f of a is less than f of a plus h. Okay, and after this there is a one more thing also. Most of the times we use that. What is that? Arithmetic mean greater than or equal to. Geometric mean is greater than or equal to harmonic means. Okay, so we use, so that's why if x is greater than 0, x plus 1 by x always greater than or equal to 2. If x is less than 0, x plus 1 by x always less than or equal to minus 2. So most of the cases we use this also. Okay? Right. So with this one, I'm concluding the session. In the next session, I'll be dealing with the problems related to this maxima. Thank you. See you later.